Hi, in this video, we are going to start talking about confidence intervals in terms of how to create them and what exactly they mean and how to interpret them and all that good stuff. So as you saw in the last video, we talk about means and proportions. This confidence interval here, or this first section here, we're going to talk about confidence interval for population mean. And this is a situation where the standard deviation is known. So we know the population mean and standard deviation, and we want to find the confidence interval eventually. We'll do that down here. So right now, we're just looking at the different components of how to make a confidence interval. So in a random sample of 12 adults from South Carolina, the mean waste recycled per person per day was 1.4 pounds. And the population standard deviation was 0.3 pounds. Assume the population is normally distributed, find Z and the margin of error. I got really short all of a sudden. Okay, so to find, when you have this, whatever, it's just going to be weird today, I guess. For problems with the population mean with the standard deviation known, we are going to be using Z. We're going to find the Z score. And even though this is really bugging me. We're not totally using it too much. We're not doing a lot of these calculations by hand. You still need to know which table, which scale we're using. And right now you only know Z, so that's why I started here. In the next video, we'll talk about other options. Okay, so we are trying to find just Z, the Z score, and the margin of error. Margin of error we talked about in the last video for a 90% confidence interval. Okay, so we're going to go to this calculator over here. This is all the information that we need to put into the calculator for, well, I don't need to highlight it. You'll see in a second for the confidence intervals. So we're going to go down, and now instead of distributions, we're going to do inference. So we're going to spend time in this category for a while. And I've said that this is a confidence interval, so you can see the second choice is intervals, confidence intervals. Okay, and we are doing one mean, because this is the population mean, there's just one of them. And it says T or Z as the choices. Well, we're doing Z right now. That's all we know, and you could tell because it says Z. But anytime there is a population mean, when you know the standard deviation, you're going to use the Z score, the Z interval. Okay, so we are going to input what we know. Anything that we're not using, we will flesh out throughout the rest of this section and the rest of the chapter. So we're just going to start right here with input statistics, input what we know. So we know that in this random sample of 12 adults, the waste was 1.4 pounds. So we have 1.4 is our sample mean. And then we know the population standard deviation was 0.3 pounds. So right here it says sigma population standard deviation. I'm going to type in 0.3. And there were 12 adults, so I'll type in my sample size is 12. And last but not least, the confidence level, it says 90%. So I'm going to type in 0.9 or 0.90. So all of these numbers in the problem, so the sample size was 12. The mean was 1.4, the standard deviation was 0.3, and then the confidence level was 90%. So all of the numbers got put into the calculator, and then we hit OK. Oh no, now we hit OK. Get down to next and then hit OK. And then we can see Z, and we can see the margin of error. We're not going to do standard of error because we talked about, margin of error is what we talked about last time. So let's write down what we're looking for. Z is 1.65. Remember we talked about rounding Z to 2 decimal places. And you just read the instructions. If it's anything different, I will tell you. And then the margin of error is 0.14. So that's the number that we add and subtract from that middle point to get the confidence interval. Okay, So far, so good. So let's try this again. Marathon times are normally distributed with a population standard deviation. So again, we know this population standard deviation is 14. The population mean we don't know. Now let's look back at the calculator. Sample mean, population standard deviation. So when it says we don't know the population mean, that's okay. We don't need it for this. The random sample of 35 is taken and results in a mean of 280. So the sample mean is 280. Find Z in the margin of error with a 98% confidence interval. So I go back over here, I type in my mean is 280. My population standard deviation is 14. My sample size is 35. And the confidence interval is 98%, so 0.98. And we have our Z, which is what we were asked for, 2.33. And our margin of error is 5.51. All right, so far so good. So what exactly are we using for any of this for? Now, we talked before how a confidence interval can be written as X bar minus the margin of error and X bar plus the margin of error. So we could actually find the margin, the confidence interval for both of these by just using that formula because we're already given X bar. So for this first problem, if we would do 1.4 because that was our X bar. Well, why don't I just do this one because it's already up from last time. X bar. So this would be 280 minus our margin of error, comma, 280 plus the margin of error is our confidence interval. And I'm just going to rewrite that as a number. So I go back to calculation and I have 280 minus 5.51, 280 plus 5.51. And so for this one, the confidence interval is 274.49 to 285.51. And so what does that mean? What did we just figure out? So what we're going to focus on next is interpreting. So our interpretation here with, and I'm going to say this with this problem in mind. So with 98% confidence, the population mean of the marathon times is between 274.49 and 285.51 minutes because our units is minutes. So that's where we're headed. We're trying to say how confident we are that the population mean, which is unknown in both of these, is in that interval. The more confident we are, the bigger the interval. Just think about a target. Let's say you have a target you're trying to hit that's very tiny, you're going to be less confident that you could hit it. But if you have a target like the whole size of your whole wall or your whole something really big, you'd be more confident that you could hit it because the target's bigger. So with the confidence interval bigger, we are, confidence, there we go. Confidence interval is bigger because we're more confident. This confidence interval is going to be smaller because we're less confident. Okay, that's kind of hard to visualize. I will show you an example on number 3. I'll show you what I'm talking about. So number 3, we want to find and interpret, wrong function. We want to find and interpret on this one. So it says the number of math majors at universities are normally distributed and have a known population standard deviation of 43. So what that tells me is that we are going to use the Z. Let me just remind you. And again, this is all we know. It's always easy the first day because we don't have to make any choices. So we go here to one mean, because that's what we're talking about in this section. And then we're going to choose the Z interval because we have known population standard deviation. Okay, a random sample of 46 universities. There's my N is taken, and it gives a sample mean of 567 math majors. Find and interpret confidence interval for 90%. So my X bar is my sample mean, which is 465. I don't know why I keep saying 567. Standard deviation is given as 43. Our sample size is 46, and our confidence interval or confidence level is 90%. Oh, okay. I was wondering what would happen if I did that. I didn't do it on purpose, but look, it says forbidden. So I literally typed in 90. 90% is 0.90. Okay, good to know. Next, and we have our Z-score, because we're talking about Z, because we are talking about a known population standard deviation. And we have our margin of error, and we have our sample mean right here. And so we can just start with our confidence interval, which would be our mean, 567, minus our margin of error, 10.43, getting that directly from the calculator right here. And then 567 plus 10.43. So I'm going to calculate 567 minus and 567 plus. And so we end up with our final confidence interval of 556.57 to 577.43. That's our interval, so that's what it means when it says find. And now we want to interpret. So when we interpret, we want to write this sentence right here and just fill in the blanks. So for this one, we say with, oh gosh, why is this all popping up? Okay, oh gosh, undo. With 90% confidence, so I'm filling this sentence, I'm writing this sentence, so I put 90%, because that's what we're talking about. The population mean of, and this one we're talking about the mean number of math majors at universities. The mean number of math majors at universities. So that's what the ... means, is fill in what you're talking about in your problem. And then I will continue with is between 5, so yeah, we'll just do this to 2 decimal places because it doesn't say otherwise. Between 556.57 and 577.43 people, I guess, is the units that we're talking about in this one. So the final answer is just going to be a sentence that's written with this guideline right here, and you fill in your information. So we're starting to get to the point where it's like, you ask the word problem, so we're going to answer with words, and just day one, so the words aren't too fancy, but we're going to just add more words as time goes on. Okay, so let's try that again here. The amount of insurance claims that restaurants submit each year are distributed with a population standard deviation of 2.2 claims, unknown population mean, that's fine. A random sample of 51, there's our N, is taken, and it results in a sample mean, there's our X bar, of 25 claims. Find and interpret 99% confidence interval. Okay, now there's one more thing to show you on here that we haven't gotten to, and that is, yes, go back, I got to type in this information. So we have a sample of 50, no, we want X bar, mean of 25, standard deviation of 2.2, a sample of 51, and a confidence level of 99%. Oh gosh, why is it just this? Okay, so we have next. We see our Z, we're in the right place, margin of error, all that good stuff. Now watch what happens when we go to the next. So again, you can see up here, one sample Z, confidence 0.99. The next page is going to show us our confidence interval, which is what we were just doing up here. It has the, well, let me just go back real quick. See our margin of error is 0.79. Then you can see that right here, they took our mean of 25, and then they added and subtracted the 0.79. So this is a little, doesn't really zoom in very much. It looks like our confidence interval is 2 point. This way we don't have to go back and forth because it's kind of hard to jump, not hard, but just kind of annoying to jump back and forth. I think that's just 24.21 to 25.793, so 0.79. That is our confidence interval. Now watch what happens to the interval as we get less confident. So remember I said, if you're very confident, I'm very confident I can hit a big target. I'm less confident that I could hit a smaller target. So if we go up here and we go, I'm very, very confident, 99.9%. Look how big that interval is. I'm adding and subtracting 1. So it's like 24 to 26. But as I move up and I get a smaller and smaller confidence level, 99, 98, 95, that margin of error is getting smaller and smaller, and that interval is getting smaller and smaller. So that we can kind of picture it that way. And you can get even smaller, it just depends on the number that you type in right here. That's where it starts. So to finish this problem, we say with 99% confidence, the population mean number of insurance claims that restaurants submit each year is between, and then we have our two answers, 24.21 and 25.79, and our unit is restaurants. No, claims. The mean is 25 claims. The standard deviation is 25 claims. So our units is claims. I guess up here, well, first of all, I spelled and wrong, but I guess I could have said students. Maybe that's more accurate than people, because it says standard deviation is 43 students. The mean math major, yeah, whatever. Students, people, doesn't matter. Okay, so we have found a confidence interval. We have interpreted the confidence interval, but for all of these so far, we were given the mean, standard deviation, and n. What happens if we're not? So looking at number 5, it says the following data represent a random sample for the ages of 30 players in a baseball league. Assume that the population is normally distributed with a standard deviation of 4.1. So it does tell us the standard deviation of the population because we can't calculate that. And we do know there's 30 players, so that's n. Don't use Excel, use your calculator to find the 98% confidence interval for the true mean age of the players in this league. Round your answer to 3. Okay, so go back to where we started. We are doing means. Well, let's go all the way back. So inference, same. And then intervals, same. Mean, same. Z, same. I didn't mean to go all the way back. I'm just letting you know this is all the same. But now instead of input statistics, because remember, if I input statistics, the first thing it asks me for is the mean. So what I'm going to do is I'm going to use a data set. Now you could just find the mean of this, that's fine. But remember, we're clicking less. That's what I just did in the last thing. So we have use a data set, and now it gives us the same way we would have found it anyway. But now I can just type it in right here and not have to go back and forth. I'm going to type in all these ages. 30, 21, 31, 24. I guess I don't need to read them out loud. Hopefully you are typing these in as well, so that way you are learning how to use this. 1, 2, 3, 29. I'm on the second row. Got 326s in there. Am I going to make a mistake? Maybe, because I'm talking. So if I typed in something a little wrong, forgive me. We're just trying to get the main idea of how to use this new technology. 1, 6. Since I'm talking while I do it, yeah, problems happen. Okay, so I entered the last one in. Ooh, look at all those that I entered in. I don't need to go back up to the top, but just to see, you can scroll up. So once you type in the last one, then you go down and it says, what's the standard deviation? Okay, 4.1. I don't know why it says 2.2. Maybe that's the last thing I did when I was playing with it earlier. Maybe it just always says that. I don't know. But 4.1. Oh, maybe it says it because we typed in a 2.2 earlier. Doesn't matter. We have our data set. We have our standard deviation of 4.1. Our confidence level is 98%. And notice it didn't ask for N. Next page, it tells you N right here. It knows. So that's a good check. If this does not match what it says in the problem, you either missed a problem, you missed a number, or you put too many in, depending on what yours says. So since it says 30 and I have 30, that means I got all my ages. And now I have my sample mean, sample standard deviation, which we don't really need. And then here's our Z, our margin of error, all the stuff from before. So here is my 98% confidence interval. This one just says to find the 98. It doesn't say to interpret it, but we can still interpret it. So it says to round to 3 decimal places. So I have 26.792. I don't know why it says round to 3 decimal places if we're talking about ages of people, but okay, that's fine. We'll do what it says. 30.275. So to interpret that, we say with 98% confidence, the population mean age of players in this league, or just mean age of players, is between, where did my ages go? Is between, I don't know why it's just popping up and it's not letting me see the ages. Okay, well, it's on my calculator. 26.792 and 30.275, and ages are years old. Perfect. I love it. Okay, last one. Do we have marathon times? That sounds very familiar. Oh, marathon times. That's fine. And this is half marathon times. Okay, I'm checked. Oh, it's not the last one. There's 3 more. Oh. Now I remember. Okay, so now is your time to practice 6, 7, and 8. So go ahead and finish up this worksheet using all the buttons. And I just want to make sure you know how to click through everything and then upload the whole assignment. Upload 1 through 8, or just 6 through 8 is fine. You don't have to do the first 5 because we did them together. Yeah, 6, 7, and 8, whatever you want. To Canvas when you are done. Any questions? Oh, not seeing any hands. Just kidding. I think I've made that dumb joke more than once. Okay, so email me if you have any questions, especially on how to use the calculator or what this all means, and I will see you in the next video. Bye.